Hi everyone, this is Abhishek. I'm an SD intern at Tandemloop Technologies and I'm welcoming you to the second session of phase 1 of Openloop. Those who have just landed at the second session and have missed the first session, let me explain you briefly about Openloop. What is Openloop? Openloop is an open source program organized by Tandemloop Technologies. In this program, you will be contributing to real projects with our in-house developers. We will be mentoring you and guiding you throughout the open source program. This program has two phases. In phase 1, that is of 1 month, we will try to learn Dart and Flutter, and in second phase, that is of 4 months, we will be contributing to real projects. If your college is not providing you any exposure to the technical world, this is the perfect place to gain that exposure. Currently, we are in the second week of phase 1. Those who will perform well in phase 1 will be selected for the phase 2, that is of 4 months. In week 1, we had completed the basics of Dart, and in today's session, we will be starting with object-oriented programming in Dart. You can rewatch the first session on our YouTube channel, and the link to that channel will be provided to you on Discord. Now let us start today's session with an intro of object-oriented programming. In object-oriented programming, we try to code for particular objects. And for those particular objects, we first create classes. And if a number of objects have same features, then definitely they will have a same class. For example, let me show you a software that I generally use. Here is dev C++. Here you can see some features that are available here, that is file, edit, search, view, and you can see that the background of whenever I click on these features, the background is almost same. You can see here the background is same. The elements that are available here, the you can say the options that are available here are different, but the background is same. Or you can say uh, this says that these all other options have same class. They all have a class in common, which can be a list view. So here you can see it has a list view. All the elements are available in a list. This option has a list view. This option has a list view. And for that class, these are the objects. So this was the intro of object-oriented programming. Now let's understand object-oriented programming in depth. For understanding object-oriented programming in depth, we need to cover some topics which are listed here, which are also the contents of today's session. The first one is classes and objects. Then we will move to constructors, then inheritance. After that, we will have polymorphism, then abstraction, interface, and static variables and methods. So let's start with classes and objects. Classes are actually the blueprints according to which different objects can be created. Just imagine you're trying to create a car. For that car, you have to first create a blueprint for that car. And that blueprint will have some of its features. Similarly, a class also, similarly, just like that blueprint, class also works like a blueprint for the objects. Here we have objects. Objects are the real products that we actually use. In case of softwares, they are like real features that are visible to us. Here in case of this example, class was a blue. Here in this example, class was working as a blueprint, whereas objects were working as different cars. Cars can be of green color, cars can be of blue color or red color. So classes generally provide a blueprint. They will have different features, all the features that will be common to all the different objects, and objects are actually the real models of those classes. Now let's move to some examples. Here we have an example of classes and objects. Here we have created a class that is cars. It will have a top speed that is equal to -1. But we know that no car has a top speed of -1. Definitely it will not run then. And it has another function, and it has a function also that is run, and that is just printing top speed, which will be definitely initially it will be -1, so it will be printing -1. Now in the main, now in the void main, what is happening, we are just creating an object. This is var model1 that is equal to constructor and bracket. What does this mean? This is actually a construct. Now our code our code moves to void main. That is our main function. In main function we are creating an object. Here you can see this line is creating an object of the cars. So here we have created the blueprint. Here we are just creating the object, the real object. This model will what this model will do when we will try to this model one is the object, and it is just this is the syntax of creating an object, and here we are just creating model one as an object, and this is the constructor of the class. And what do constructors do? They just create the objects. It's just so simple, isn't it? In real life, what constructors do? They just create buildings. Here constructors create objects. Similarly, here in the second example you can see model 2 is created, and model 2 is created with the help of this constructor. So this is how it works. Here you can see, did we created any top speed for model 1? No. Did we created any run function for model 1? No. But still, we can call top speed for it. We can call run for it. How? This all is happening because model 1 is an object of cars. That is our construct. This this all is this all is happening because model 1 is now this all is happening because this all is happening because model 1 is now an object of our class. Is it so simple? Isn't it so simple? You can read more about classes and objects in the link that I have given here. When you will click on when you will click on this link will open and you can read more about classes and objects. Now let us practice classes and objects in the dartpad. Here we have opened the dartpad and we are just trying to create a class and its objects. So let's create a class. First of all, we have to write class and then we have to write the name. So let's have the same name that we were using. And now let's create some attributes. Every class has an attribute. Attribute can be treated as data types. So we're just creating a data type or an attribute. Attribute can be treated as some data. So here we are just creating an attribute that can be top speed. And let's put some value that is actually an initial value. Here it is. Now we can create an object of this cars. Now we can create an object of this class in the void main. Let's create the void main function. And in the void main function, we can have an object. So we are just creating an object. Let's name it some fancy name that can be sx1 and give it a constructor. Now if you have no idea about constructors, don't worry, we will be discussing about them too. Now I have created an object that is sx1. Now I will just try to print the top speed for this sx1. Print and then sx1. Now if I want to use top speed, I have to use dot then the name of that variable or the attribute, we can say. So here I have used that. Now let's see what will happen if I try to print it. If I try to run it, then it is printing 100. So we can say that if we create some other objects of the same class, let's create sx2, let's create sx3, and if we try any one of them, it will give us the same value. The value will be copied to all the objects. So what we can observe here, that we have just coded once and now we are using the same code for different objects, right? So this is the benefit of using classes and objects. Now let's move to the slide. So here we learned basics about classes and objects. Now let's move to the next slide. Now we are going to understand what are constructors. We have already talked about constructors. Now let's understand them in depth. What actually constructors do, that they just provide initial values to the objects. For example, here in this case, I have a car. For example, in this case, I have a class that is cars, and it has here it has an object, and here it is initialized by its object that is cars, and it is just passing 60 and red as values. So here this constructor cars is actually an parameterized constructor. You can see parameters are passing through this constructors, and they where they are going here in this speed and this color. What are this speed and this color? We will discuss about that. So this constructor is just passing 60 and red, and what will happen actually, model 1 will get the value of speed and color as 60 and red. So we can say that for model 1, the initial values are set as speed equals to 60 and color equals to red. So with the help of constructor, what we do, we just give initial values to our objects. This is the main purpose of the constructors. Hope you understood this. If you want more about this, if you want to learn more about this, you can click on this link and you will get more resources. Now let's try to code this. Here I had an example, right? What I am thinking of, let's change this value, that is 100 for all the objects, to some different value. What I can do, I can create an parameterized constructor. Here we have an parameterized constructor, that is cars, and parameterized constructors are formed in just the same way we create. Actually parameter actually parameter actually parameterized constructors are created in the same way that we create the functions, but the difference is but the different is but the difference is that they don't return any value, first thing, and the second thing is they just initialize the value. The third thing is they don't return any value. Here we had top speed equals to 100, but it was same for all the objects. But what if I want xs1? But what if I want sx1 to be having a top speed of 200 and sx2 having a top speed of 50? Then what should I do then? What I can do, I can create a parameterized constructor, and here I'm creating that cars and bracket, and this dot top speed. Now this will do, this will ask for a top speed from here. So if I am just passing some value, let's say 60, if I'm passing 60 here, what will happen, 60 will go there, and what will happen for this, let me add a semicolon, for this sx1 model, the top speed will become 60. Similarly, if I pass 70 here and if I pass 200 here, what will happen, the values of top speed will change for different models. And if I try to run it, what will happen, for sx1 you can see the value is 60, and sx3 that I printed, the value is 200. It is working fine. So this is the main purpose of using so so this is the main purpose of using constructor, to just give an initial values to our to just give the initial. So this is the main purpose of constructor, to just give the initial values to our objects. But what was happening when I had no parameterized constructors, right? So if I remove this, if I remove this and this one also, actually what was happening, that there exists this there still exists a constructor, but it is a default constructor. And what this default constructor will do, it will just initialize sx1 with a top speed of 100, sx2 with a top speed of 100, and sx3 with a top speed of 100. So there are types of constructors which do different works. Here we have discussed the default constructors and the parameters constructors, right? Hope you understood this. Now let's move to the next slide. Here we have named constructors. What are named constructors? So what was actually happening, that we were only able to use one constructor. But suppose if some suppose if some object is asking for 3 parameters and some object is asking for 2 parameters, and we have only one type of constructors. So what that constructor will do? That constructor will either that constructor will that constructor will either pass 3 values or 2 values, right? Here comes our superhero, that is named constructors. Here we have an example. You can see here we can create a constructor which has a different name. You can see here cars.custom. Here custom is the different name for this constructor. Now here I have added 2 parameters, but you can add 3 of them. Let me show you an example now. Here we had created a cars constructor, right? Here we had created a class, that is cars. Now what I'm trying to do, is that I'm just trying to create a constructor that is cars, and it will have 2 parameters. Let's say or 1 parameter, top speed. So this dot top speed, right? What this will do, this will just give whatever the values are passed here. Like let's say 200 is passed here, it will just pass the 200 to the objects, right? This will just give an initial values to sx1, sx2, sx3. Now if I create another constructor, let's say cars, and this dot top speed. Now, and let's give another attribute. Let's create another attribute first of all, where let's say break, right? Breaks, that is equal to, let's say, one break is there, right? We have created breaks, and now we want to have this dot break here. What will happen? What do you think? What will happen? It will give an error, right? It is giving an error. If I pass some values, let's say someone wants 3 breaks to be there in his cars. So now it is not possible, because we don't have any constructor related to that. Like we have tried to create a constructor which has 2 parameters, but like it is not working, because it is a rule, you can't do this. You can't have same name for 2 constructors. So what we can do, we can create a custom constructor, a different constructor. Let's name it some other like let's give it a different name, unique. Let's Okay, it is enough, I think. Okay, let's give it a small name, some unique constructor that we have. And yeah, this was also missing, s should be there, right? Now can we use it? Now as we have created a custom constructor, we have to use that custom constructor here. So we can name it like this, and the same thing we are going to do with this one. Right now it will work fine. It is running. Yeah, can you see this? For this it is giving 200, and for this, as we just asked for top speed, it is giving us top speed. If we ask for the brakes, if we ask for the brakes, how many brakes this car has, so let's say brakes, what is the spelling of brakes? Yeah, okay. If I run it, what will happen? Let's see. You can see 2 is here because we have passed 2 in this constructor, right? So this is the way how we can create a constructor which has same class, but we can have different names for that, for those constructors, right? A single class can have multiple constructors, but their names will be different, right? So this was all about named constructors. You can learn about named constructor here with this help. You can learn more about named constructor with this link that I've given you. Now, inheritance. Now we are starting inheritance. Inheritance. Have you ever studied inheritance in biology? No? Don't worry. We will study that in today's session. What inheritance says, that if you're creating a class A, okay, and if you are creating a class B, which may have the same features, which may ask for same features that class A had, then why are you coding the same thing for class B? It is not required, man. You can just inherit those features from class A. This is so simple. Why don't you do this? So the same thing is happening in inheritance. Here you can see an example. Here we have class that is cars, we have a class Tata, we have a class Toyota, and you can see here some blah 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 codes. Okay, so what this code is doing actually, cars had some features, or you can say some attributes and some methods, and Tata wanted the same methods and attribute to be in its class itself, and Toyota and same thing for Toyota. So what we did, we just extended Tata for the from the class cars. So what we are doing actually, we are just inheriting these features. What are the features? String colors, void stop. So these are the two features that, or you can say the attributes and the method are there in the class cars. So we will just inherit those features in the Tata. Now Tata can also use colors and stop. Same thing is for Toyota. Toyota can also now use color and stop. Here we have an evidence. We can see here we have created model 1, that is from Tata, and we have created model 2, that is from Toyota. Right? These are the objects actually. Here you can see a magic, that model 1 can use color that was not available in the Tata. It was only available in the color that was cars. So model 1 can use color, model 1 can use stop also. Similarly, model 2 can use color, model 2 can use stop. Now color and stop were not coded under Toyota or Tata. So this is the main thing in the inheritance. We just code for a particular class, and now if the feature or the attributes and methods are usable for different classes, we can do inheritance in that case. You can read more about inheritance here. We are just going to code it for more practice. Now let's see some codes for inheritance. Here we have created a class, or just we have just initiated a class that is cars, and we'll just write some code in the cars. Let's say if we are creating a variable that is, let's say, top speed. Let's give it a value 100, and what we are doing, we are creating another car company. Let's say we are creating another class that is Tata, that extends cars. Now, as Tata extends cars, what it will do, it can easily use top speed. Now let's give some function to it. Let's say void run, and what this will do, this will just print running, right? So what is happening actually, we are creating a we are creating a class that is Tata, and this Tata is inheriting the top speed from cars. Okay, now let's create an object for Tata. So variable, that is, it can be anything, model 1 equals to constructor of Tata, and let's end it. Now let's see, can we use run for Tata? Let's see, can we use it? Definitely, of course, we can use it. There is nothing miracle here. Can we use? Can we use? Now let's see. Can we use top speed for Tata or model one? Let's see. Model one dot top speed. But top speed is a what? Top speed is a variable, right? It is a, you can say, an integer, right? So we can print it. So we will just use the print function. The print function, we can print the value if it is giving. So if model 1 has a value 100, then it will print like this. So here we can see how we can inherit the properties that are available in other class to some other class, and this is called inheritance. Okay, hope you understood this. Let's move to the next topic now. Here we have polymorphism. Here we have an example of polymorphism. Hope you will understand polymorphism with this example. Let's say God has created some sound, some feature sound, and what he did, he gave this feature to some cow and some cat. Okay, now what was happening? Cow was having the same sound and cat was having the same sound. This was a problem. So what God did, he just modified sound and converted it into moo. Okay, the sound was like different. He just modified the function, or like you can say some features of like some attributes or some methods of sound for cow and for the cat. So you can say here was class A, here was class B, here was class C. Class A had some features, or you can say a method and uh, some variables, or you can say some attributes. And what happened actually for class B, the class B just inherited those features, but with some it overrided some features, or you can say some methods of this class A. And same thing for the class C. Let's see the code and we will have a better understanding of this. So here we had a class cars. Here we had a function, or you can say method, that was speed, and it was printing 10 kilometers per hour. But we wanted a class that is Tata. It, like, we wanted that this function should like we wanted that this class should have this speed function, but there must be some modification in that, right? So what we did actually, we created the same function, we had same features, everything was same, but what we did actually, we just printed 30 kilometer per hour here. What we did, we just printed 30 kilometer per hour. So for all Tata, the speed will be changed to, from, like, here we are just printing something. Maybe in some code we will be assigning some values to in some function or method, or maybe we will be like running some for loops. Okay, so anything can be there, right? So here we are just showing that in parent class speed was something different, and in the child class speed is something different. Here we can also call the function that was available in the parent class as same. Here we have super dot speed. So this super dot speed will print 10 kilometer per hour. Like if we want to print the same function, we can do this. Let me show you an example. Let me show you show you the code for this. Okay. So remove it. Let's remove it because it is not needed here. Let's use some function like print, right? Print hi. Okay, and let's say he's some guy, right? Okay, G should be capital. Always remember that G should be capital. Like for a class, first letter should be capital. Remember this. Remember this thing. First letter should always be capital, guys. And let's have some boys. Okay, here we are just printing something, and sorry, I didn't created a function or method actually. Let's create a method also, void uh, greet. Okay, let's see, create greet, and this greet, what will this do? So just print hi. Okay, and we just want for boys, like boys are also guys, but we want the boys to just say hello, right? So what we will do, we will just override it, right? Now we will just create some objects. Okay, let's say Harry is some object, and it is inherited by boys. He's a boy, right? Right? And wait, there must be treat, right? Let's print, let's call Harry dot greet. Okay, so you can see that a parent has a greet and the child has a greet. Now what will be called first? Let's see, right? Let's see what will be called. So you can see hello is called. This is called polymorphism. Greet has a name here and the same name is used here. You can say same name but different works. This is polymorphism. So this is polymorphism. If you want to know more about this, you can go to the learn more section and you can click on this link and you will get to know more about polymorphism. Now let's move to the next topic that we have. That is inheritance with constructors. Inheritance. Hey, wait a minute. We have studied inheritance for classes. Now, what are inheritance for constructors? Let's see. Now, here in inheritance with constructors, what actually happens? Let's say here we have a parent that is cars, and here we have a child class that is Tata. And here we are just trying to create an object of Tata class. And what will actually happen, that if we are just creating an object, its constructor will be called, right? This actually happens. We know that constructor of the class will be called. We know that. But what will actually happen behind the scene, that constructor of the class for which this object is created will be called, as well as the constructor of the class which is the parent of this class here, Tata. The parent of Tata, that is cars, its constructor will be called also. So what will happen actually, this Tata's constructor will be called, as well as cars constructor will be called, when we will just initialize this model one. When we will create this model one, both the constructor will be called. Why? Because this is the constructor. Why? Because cars is the parent of this Tata. This happens. Let me show you an example. Here we have two classes, right? Let's remove this part. Okay, and let's remove this part also. Let's create some variable. Let's say some number like ice. Okay, ice, that is equal to, let's say, brown. Okay, okay, or leave it. It is not required. Let's call the constructor of guys. Okay, let's call the constructor and try to print something in the constructor. Okay, we can print something, or we can do one more thing, that we can initialize something also. So here in this example, we have a parent class, that is guys, and a children class, that is a child class, that is boys, right? Here we will just call the we will just uh, we will just modify the constructor. We will just modify the constructor for guys, and we will just try to print something. Whenever this constructor will be called, something will be print, that is, let's say, hi, how are you? Okay, this is just an example. Okay, don't relate it with class and object. Just I'm just giving an example. Okay, so it will print hi, how are you? Okay, and when boys constructor will be called, boys, this constructor, when this constructor will be called, what will happen? Print, let's say, I am fine. Something like this will be called. Let's say. Okay, no problem. I think, right? Now, let's create an object. We are just simply creating an object. Here you can see Harry is an object of the class boys, right? So what should happen? This constructor should be called. This constructor should be called only, right? This should be happening. This should be like only I am fine should be like there in the console, right? So if I run it, let's see what is happening. Can you see? First of all, the parent class is called. The amazing thing is this: the constructor of the parent class is called first. You can see here. Then the child class, the constructor of the child class is called. So this is what we say inheritance in constructors, right? So constructors are also getting inherited from the parent to the child. So this was the concept of inheritance in the constructors. You can read more about the this concept here, and I will also give you a question related to this. Try to practice that and solve it. Okay, let's move to the next topic. And here actually the output is, okay, let's move to the next topic, that is abstraction. What is abstraction? What actually happens, that we just try to create simple classes, and we just try to modify or add new features according to the object we want to create in the next class. So what we are here trying to do is, let's say we wanted to create car as well as a cycle as well as some boat. So we could have done one thing, that we could have created some some vehicle, then we could have created some car, this type of model, then we could have created this separately, and similarly we could have created some two-wheeler, and then we could have created some class that has some other like wheeled vehicle, and then we could have created cycle. Similarly we could have created simply vehicle and then this boat, right? We could have done this, but the we always try to reduce the size of our code, right? So for that, what we can do, we can simply start with vehicle, then we can create wheeled vehicle, then we can create some changes to this vehicle, and we can create wheeled vehicle, another class. Okay, it will have some different objects, like it may have some different subclasses or child classes. And vehicle has, you can see here, we have boat, right? So boat and all these classes you can see here have the same features as vehicle. So we coded vehicle once, and we use them that code for these two partitions, right? This one and this one. Similarly, we coded wheeled vehicles, like vehicles those who have which have like wheels, right? We coded them. We coded a class for them once, and then we are using that for different objects, right, or classes, right? We can use them for different objects, or we can use them or inherit those features to different classes also. So this is what happening in abstraction, right? Let's see an example. Here we actually created an abstract class, that whose value was initialized as like x. Some x value was there, some y value was there. It was initialized as -1 -1. It had some abstract method, and abstract method are generally like those methods which are supposed to be defined by the child, right? These are those methods actually. So here we just created an abstract method, and the run is here a simple method, right? Abstract method is this one, which is not defined in the parent class. So abstract methods are those methods which are to be defined by the child class. So here we can see we have created a child class and we just defined it, right? So this is what we have done, and now we can just use it for model 1. We can use get fuel and we can run it, right? It is so simple. We don't need to like confuse and this kind of things, right? Okay, let's code it once. So here we can see an example. Let's say this is an abstract class. Now in the in this part you can see how to create an abstract class. So parent class should be an abstract class for this. So parent, for creating an abstract class you have to write abstract here before the parent class. Okay, class cars should be started with abstract word, right? Keyword, right? So let's start. Here we have to first of all write abstract, right? Now it is an abstract class. Now whatever, like if we create some function like this one, void let's say run, and if we define it, some if we write something here, then it will not be called as something we can say like, abstract class, abstract function or method. If we leave it like this, just leave it like this, then it will be called as an abstract function, right? Now why it is showing an error? Why? We didn't change something for this one, then why it is showing an error? It is showing an error because it is compulsory to just, you can say, modify this run, or you can say override run. You have to define what is happening with run in the child class. It is compulsory, right? Here you can see the error: missing concrete implementation of guys dot run, right? So what we can do, we can just modify run. Void run needs to be modified. Now you can see the error is gone, right? And we are just printing that running, right? It is so simple, and we can simply call it here harry dot run. Okay, so this is especially used for those features, or if you want to create some feature in your project in which you just want to write, you can say write all the features that are required in your code in a list. You can say, you what you will do, you will just you will prepare a list of all the abstract functions that you need, actually all the abstract methods that you need. You may write all those methods here, and just like you can do anything. Okay, just do it like this: run, or do anything, or fly, right? What you're doing actually, you're just declaring them here, right? Get fuel, you're just declaring them here, and you are just modifying those functions here, and you have to modify all of them for a particular child class. You have to modify each one of them, right? Initially they are not doing anything, so you have to override them here. So until like if you don't override them, yeah, if you don't override them, your code will show an error. Here you can see this, right? So it is compulsory to override. Currently I'm not doing this. I will just print it and see. Here it is printing it. So if you if you want any function, or if you want some function to be you can say overrided by all the classes, all the child classes of that parent class, then you can create an abstract function, abstract method, and that can be done with the help of this abstract keyword. So for that you have to create the whole class as an abstract class, right? So this was all about the abstract classes. You can read more about the abstract classes here over this link. Okay, now let's move to the interfaces. Earlier we studied about abstract classes. In abstract classes we were able to create it In abstract classes, we were able to create abstract methods as well as simple methods. But what if we want only abstract methods to be in our class? So for that, we can do one thing. Here we can see an example that we have created a class, that is parent class, and it is cars. And here we have an function that is that is tires. And here we have a child class that is data, and it implements, not extends. It implements the cars, that is parent class. Now here we have created an interface. What is happening here actually, it is like when we create an interface, it becomes like you can say, it becomes compulsory for the child class to override each and every function or method of the parent class. So we can say all the methods of the parent class are now abstract methods. So this is the same thing that happens in the interfaces. What are interfaces actually? In case of interfaces, the child class overrides all the methods of the parent class. Either it is like declared as a abstract class or not, it doesn't matter, it has to modify that class. So this is the same thing that is happening here. One thing is there, we can't call super.tires, like this will be like totally gone. Like some tires you can see here, like it is printing some tires, its definition will be totally gone in the child class. We can call it, right? And here it is an example. Let's code for it, right? So here we have a parent class. Let's remove this abstract keyword, it is not required here. Now we are just defining it, right? Let's give some value. Let's print something. Okay, now it is compulsory for the child class to override it if we implement it. Implements, right? Now it is compulsory. Okay, if we remove it, what will happen? Let's see what will happen. We have removed it. Now it is showing an error, but the class is not abstract. Why it is happening? Because now it is an interface class, right? So here you can see we have to define it, right? So we need to define it, and it is compulsory. Void, and let's say run. Oh, yeah, definitely it was run. We have to do this, otherwise it will show an error, and we have to override it, right? Now the same thing will happen, right? So this was all about what? Interfaces, right? Now let's move to the next topic. Now finally, the last topic that we have is static variables and methods. In static variables, what actually happens, that if we want to create some methods or some variables that are to be just modified only by the class, that class in which they are defined. If you want some variables like that or methods like that, you can create static variables, right? You can use the static keywords here. Here you can see the keywords static. Okay, what they are doing, they're just creating a static variable. Here they're creating a static tired, okay, and here we are creating an function, a function that is fly, and this fly can't be like override by any other, you can say child, okay. Any child can't do this, right? So let's code for it. What we are doing, just we are just like making it static, right? And let's create some static variable that is, let's say top speed, right? If we create some object like guys, right? Here we are creating a guys, and you can see run that is available here is now, but now we are not use, now we are not able to call it with the help of the object of the guns. Why it is happening, let's read it. The static method run can't be accessed through an instance. Try using the class guys to access the method, right? So it is saying that use guys for doing this, okay. You can't do this, just use guys like this, right? You can do only this guys dot run, this can be done, okay. Now it will work, right? So this was all about static variables, and this so the, so this was all about static variables and static methods. Same thing is for static variables also. Let me show you this. Guys dot top speed. But if I just like try to call Harry, or try to print Harry dot top speed, right? If I try to do this, now it is again showing an error. This static again, the static problem is there. So we can't do this. We have to just remove it, guys. And it gives some, like, they are used in a lot of things. They are used in different ways. Like you will see how static variables and static methods are useful in future, right? So currently, just understand how static variables and static methods work. What are their use? We will discuss about them. So these were static variables and static methods. Now, so we have so we have covered almost so we have covered all this top so we have covered all the topics for today's session. Now it is time to end this session. So thank you for joining today's session. We have covered a lot of topics for object-oriented programming in Dart. I think now all you need to do is just go and practice all the codes that I have shared today. Even also go to the links that I have shared. I will also give you some questions for practicing. Just go and practice them, and I think after that, when we will meet on next Saturday, you will be fine, and or you can say perfect with the object oriented programming in Dart, right? So hope you will learn well. We will meet on the next Saturday. Goodbye.